Hi, today we're going to be talking about matrix multiplication. When you can use matrix multiplication, how to use matrix multiplication, and some of the properties for matrix multiplication. We can use matrix multiplication basically when we have a matrix times another matrix. So if we had matrix A, we'll call it. We'll have matrix A times matrix B. Okay, well, if we have matrix A times matrix B, then in order to multiply the matrices, the inner dimensions have to match. In other words, if M by, let's try a different color, N is multiplying something like N by O. Okay, these inner dimensions, so it goes rows by columns, so the columns of the first matrix has to be the same as the rows of the second matrix. Okay, if those two are the same, we can multiply matrices. So in other words, if we were taking a matrix that was a 3 by 2 and multiplying it times a 2 by 1 matrix, so a 3 by 2 would be like, let's see, 2, 1, 3, 5, 4, 7. That's a 3-row, 2-column by a 2-row, 1-column, so like 4, 3. Okay. We could multiply those two because the inner dimensions match. So a 1, 2, 3rd row, 2 columns times a 2-row, 1-column matrix does work. Okay, so and the other part is then what does it give you? It gives you these outer dimensions. Okay, so this will give us, here it would give us, so if we multiply them, it's going to give us a matrix of a M by O, the outer dimensions. So number one, the inside dimensions have to match. Number two, the outer dimensions are the resulting matrix. So this one over here, the outer dimensions are these two. So it's going to make a 3 by 1 matrix. So that's how we know, number one, can we multiply matrices? The inner dimensions have to match. And number two, what does it actually give you? Okay, so that's the first thing you need to understand before we can do any matrix multiplication. The inside dimensions match, the outside dimensions are the result. Okay, how do we actually multiply the matrices now? If you take a look at this example, here's how we, let me see if I can get to this. Here's a 2 by 2 matrix times a 2 by 2 matrix, so it's going to give you a 2 by 2. What you do is you take the first, if you're trying to get this first row, first column, you're going to take the first row times the first column. So A times E plus B times G. Okay. So give this one a shot. See if you can figure out what this resulting matrix of U times V would look like. Hit pause. Alright, so whenever I set up this again, I want to double check, can I multiply these first? This is a 2 by 2 matrix, and this is a 2 by 2 matrix, so yes, the inner dimensions match, and the outer dimensions are a 2 by 2, so it's going to give me a 2 by 2. So I start with that, and I actually give a blank matrix, and I write out, I know it's a 2 by 2, so that's, again, 2 rows, rows go horizontally by 2 columns. Columns hold up buildings, so that's how I remember columns are the vertical there. Alright, so if I'm looking at this first area here, okay, that's the first row, first column. So I'm going to take the first row here, multiply it by the first column here. So that's going to be the 5 times 2 plus 9 times 6. Okay, so that's again first row times the first column. Okay, so 5 times 2 is 10, 9 times 6 is 54. All right, add those together and we get 64. Okay, all right, if I'm looking at this blank here, that's in the first row, second column, so I'm going to take the first row times the second column now. So that would be 5 times negative 1 plus 9 times negative 5. 5 times negative 1 is negative 5. 9 times negative 5 is negative 45. So that would give us negative 50. Okay. Moving on, I'm looking at this spot now. That's the second row first column. So I take my second row of the first matrix, multiply by the first row on the second matrix. Second row first column. So that's negative 3 times 2 plus negative 2 times 6. Okay, negative 3 times 2 is negative 6. Negative 2 times 6 is negative 12, so that's negative 18. And then finally, this part is the second row, second column, so I take my second row times the second column. That gives me negative 3 times negative 1 plus negative 2 times negative 5. That's positive 3 plus 10 is 13. Okay, does matrix multiplication, or does the commutative property of multiplication work for matrix multiplication? So we're trying to find, that's a fancy way of saying, does A times B equal the same as B times A? Okay, so what I want you to do is I want you to multiply these two matrices, find out what A times B is, then find out what B times A is. If they're the same, we know that the commutative property of multiplication does work. So go ahead and hit pause, multiply those two in different orders, go. Alright, A times B, so again, it's going to give me a 2 by 2. So first row, second row, okay. So let's see, to find this spot, that's first row, first column, so I'm going to take first row times the first column. So that's 4 times negative 3 plus negative 1 times negative 4. 4 times negative 3 is negative 12. That's a positive 4, so that gives me a negative 8. Okay, this is in the first row, second column, so first row times the second column is 4 times 6 plus negative 1 times 5. 4 times 6 is 24, negative 1 times 5 is negative 5, so that's positive. See if I can erase that. That's positive 19. Okay, this is second row first column, so second row times the first column. That's 4 times negative 3. Oh, that's not 4. Let's try 5. Times negative 3 plus negative 2 times negative 4. So that's negative 15 plus 8 is negative 7. Okay, and then finally we've got second row, second column. So second row times the second column is 5 times 6 plus negative 2 times 5. 5 times 6 is 30, negative 2 times 5 is negative 10, so that's positive 20. Okay, if I multiply matrix B times matrix A, okay, so I'm going to write it out again. I'm going to write it as negative 3, 6, negative 4, 5 times 4, negative 1, 5, negative 2. I'm going to get a resulting matrix that is a 2 by 2. Okay, So if I'm looking for first row, first column, that's first row times first column, so that's -3 times 4 plus 6 times 5. -3 times 4 is -12 plus 30 is is 18. Well, that's already different, right? Just to show you can go in any order when you're trying to find any of these. I'm just going to check. If this one's not the same also, we definitely know that these two are not the same. We don't really have to do the rest. So that's second row, second column. Second row times second column would be -4 times -1 plus 5 times 2. So that's 8 plus 10 is 18. I can see right there that is definitely not the same matrix. Oh, sorry, that's a 14, not an 18. My bad. Still, not the same matrix there. So that shows the commutative property does not work. Let's take a look at what properties do work for multiplication. So if you look at these, you have the associative property, meaning if you go in the same order, A times B, then times C, that's the same thing as doing multiplying the B times C first and then multiplying the A, but you have to keep it in that order. It has to be, as far as once you find your resulting matrix time of the AB, that has to be on the left of C. If you're doing it the other way, when you find BC, you have to keep that on the right and multiply A on the left. So it's the order really does matter when you're talking about matrices, because we saw in the last one that A times B is not the same thing as B times A, so you have to make sure you keep that order the same. All right, scalar properties, if we have some value multiplying the product A times B, we can do, it doesn't matter if you do K times A times B or A times K times B. That constant can go and multiply at any time any one of the two matrices. Okay, the distributive property, just be careful. If you're adding A plus B, you can do, and then multiplying that value by C, okay, you can distribute that C and make it C times A plus C times B. So you can distribute, but just notice the order has to stay with the C on the left, the C has to be on the left over here. Okay, here, if you do A plus B times C, where C is on the right, then C has to be on the right over here. So the distributive property does work, but you have to be careful again, because we know that A times B is not the same thing as B times A. That does it for matrix multiplication. Please bring in any questions.